Over 4,000 years ago, the Indus Valley civilization constructed some of the most advanced urban centers of the ancient world. Their cities featured standardized brickwork and complex drainage systems, indicating a society of immense scale and organization. But while we can see their architecture, we cannot hear their voices. Despite uncovering over 4,000 inscribed objects across these ruins, we are unable to read a single sentence they left behind. The mystery is defined by these shapes. Researchers have cataloged exactly 584 unique symbols carved into these artifacts, yet their meanings remain entirely unknown. The Indus script is not an isolated silence. Centuries later, other systems emerged, like the Shankalipi script found in cave inscriptions across India, which also remain unreadable to this day. For 100 years, traditional linguistics has failed to decode these symbols. Now we are turning to modern data science to see if algorithms can succeed where humans have not. Modern researchers no longer look for a Rosetta Stone. Instead, they treat these symbols as a statistical dataset to be analyzed by computer algorithms. This chart shows a multi-metric scorecard approach. Computers compare the Indus inscriptions against two dummy baselines, one mimicking family emblems and the other mimicking a simple administrative code. One key measure is conditional entropy, which scored 3.23 bits for the Indus corpus. This metric tracks how predictably one symbol follows another, placing the script in a middle zone between random noise and the structure of spoken language. The data also revealed 43 distinct formulaic phrases, sequences of 5 symbols that repeat across different objects. This suggests the script was highly organized, rather than just decorative marks. The final statistical result is ambiguous. The Indus script doesn't perfectly match a known spoken language, but it doesn't match a simple accounting system either. Algorithms haven't given us a dictionary yet, but they confirm that these symbols possess a rigid, intentional architecture, a complex system of communication that requires a new way of thinking to understand. Using data to find patterns in history is not a new concept. In 1833, James Prinsep used frequency analysis and character prevalence to decode an earlier mystery, the Brahmi script. A major part of this discovery happened here, at the Nanegat cave system in Maharashtra, where inscriptions were found carved into the Rocky Mountain Pass. Researchers tracked how often specific characters appeared in these carvings, eventually deducing that they were reading ancient Sanskrit and Prakrit. These decoded texts held a significant secret. They contain the original prototype symbols for the numbers 1, 2, 4, 6, 7, and 9. Pattern recognition is the exact historical method that gave us our oldest written numerals and recovered the timeline of India's recorded history. Once fully decoded, the ancient Brahmi script was revealed to be a kind of linguistic DNA for the Indian subcontinent and Southeast Asia. Just as basic amino acids combine to build complex DNA, the base vowels and consonants of Brahmi combine to form intricate phonetic ligatures. This academic diagram shows how that lineage evolved. Over centuries, the original Brahmi root branched out to create nearly all modern Indian scripts, including Devanagari, Tamil, and Telugu. This systematic grid layout reflects the alphabet's logic. According to Jain mythology, this left-to-right writing system was engineered by a princess named Brahmi, the daughter of the first Tirthankara. The letters are organized into vargas, categories based on where a sound is produced in the mouth. By mapping sounds to specific numbers, ancient scholars could even hide data within verses, treating language with the precision of a mathematical grid. From the lineage of Brahmi to the statistical searches for logic in the Indus Valley seals, these scripts highlight an ancient and profound preoccupation with organizing information, a legacy that we are still working to fully translate.